Hello and welcome to the third video of 3 in our series for section 3.4 direct variation. And in this one we're going to be dealing with the final stage of the whole process, which is to actually write and solve direct variation equations. So here's what a problem will look like. It'll say suppose y varies directly as x. Now that's a key signal phrase for us because it sounds really confusing and we never talk that way in real life, and yet we should know that as soon as we see that phrase y equals kx needs to pop into our head, okay? Because that's what it means to say that y varies directly as x. It means we have a direct variation, and we've already talked about how any direct variation has the form y equals kx. So we see this phrase y varies directly as x. That means we got y equals kx. So suppose y varies directly as x and y equals 98 when x equals 14, so they give us an x and y value. We will use that to then write a direct variation equation that relates x and y. Again, fancy way of saying y equals kx. Then once we've done all that, find y when x equals -4. Okay, lots of things. It's really a two-step process, or a two-part process, I should say, with a number of steps to get there. And the first step is the simplest. Write y equals kx. It may seem silly to write it, but I'm telling you, you want to write it every time because it's going to help you visualize what it is we're actually doing and what information we have. Because as you can see with step 2, replace x and y with what we know. So we're going to take that y equals kx, replace y with 98 and x with 14. See that from right there in the problem where they give us that. Pop it into the equation. Now the only number we don't know is k, and so we'll use our rules for solving equations to solve for k. Divide both sides by 14 to try and get k by itself, and we'll end up with k equals 7. Once we know that k equals 7, we now have the information we need to actually rewrite a direct variation equation with k in it. Because remember, we started off with y equals kx. Now we know what k is, so now we can have y equals 7x. And that is our direct variation equation for this problem. That's the one that's going to relate x and y as y varies directly as x, to use the formal lingo here. So now that we have our full direct variation equation, it's time to do the last part of the problem. Find y when x equals -4. So what do? Plug a -4 in for x. Simplify that side, and there I have it. Okay, that last part really is the easiest part, but it's not to be scoffed at. A lot of kids will forget to do it. A lot of kids will make silly mistakes and plug in the -4 for y. Don't overlook that last step. Okay, plug in the -4 for x, solve for y. Okay, now again, it's not too difficult, but I'll tell you where we get mixed up. It's step 2, figuring out where the x and the y go, and then it's step 4, figuring out what to do with k once we have it. We figure out what k is, and then what a lot of kids will do is they'll plug the 7 in for k, but then they'll plug in 14 for x and 98 for y. We've already taken care of that, right? That's just one point on the line. This y equals 7x, that's my rule for the whole line. I can find any point on the line now, but if I plug in the 14 and I plug in the 98, I can really only find that one point that I've already got. So keep that in mind. The goal is to get a general equation for the whole line, and once I figure out k, I just plug in k to the y equals kx. If you can get to step 3 and do step 4 correctly, you're probably okay with these types of problems. And if not, it'll just come with practice. You'll have to kind of beat it into yourself to figure out how this works. Let's try an example. Suppose y varies directly as x and y equals -21 when x equals 7. Write a direct variation equation that relates x and y, then find y when x equals 6. Okay, same exact thing we just did, just change the numbers around. Take a moment, see if you can figure this out. Okay, I'm going to show you my work and we can compare notes. As you can see, like I said, start off with y equals kx, then plug in the -21 for y, the 7 for x, get k by itself by dividing both sides by 7. I'll get k equals -3. Then once I've got k equals -3, I plug the k in, so I get y equals -3x. There's my equation. That's the first half of what the problem's looking for. Then find y when x equals 6, plug the 6 in, I get x equals negative 18. Okay, so again, we'll practice all this stuff from these 3 videos in class tomorrow. We'll do some activities to go along with it. Your job moving forward is to make sure you've got any questions that you have either submitted to the discussion board or written down so you can ask them live in class. And that way when we can get to class together, we can jump right in, answer those questions, and get our activity taken care of. So looking forward to it, and hope you guys enjoyed the video. Watch the recap and you should be all set. Thank you.